Okay, so we're going to do a bunch of the questions today. We're actually doing questions 1 through 10 in the same video so that you guys can go through this. So there will be a little bit of a pause, but it will be a longer video today. So the steps I already wrote for you on the bottom here. These are the steps to solve the problem. Now, I see a lot of reading, and I'm going to ignore it. I'm going to go to the question first. So number 1, does the information from the physical cracking model support the conclusion that the formation of scales by cracking is common among reptiles? So, formation of scales by cracking. Yes, because crocodiles are reptiles. Physical cracking creates irregular, semi-random scale patterns. No, because the model claims that scales are formed by RDMs. RDM and reaction diffusion model sound pretty much the same, so I'm going to cross off that. No, because the scales of crocodiles are much thicker and tougher than the head scales. So now we're going to go to physical cracking. So although the body scales are generated by biochemical processes, head scales develop primarily through physical means. Crocodile skin is thick, contains keratin. As a crocodile grows, the inflexible skin cracks in a pattern similar to the cracks seen in dry mud. Unlike the RDM-controlled scales on the heads of lizards and snakes, the head scales are asymmetric. Genetically controlled processes create symmetry. Physical cracking results in irregular, semi-random scale shapes. So, the answer to number 1, let's see. The answer to number 1 for this one, does the information support the conclusion that it's common? Let's see. The model claims that, oh, I see what I did here. I'm not going to cross off this answer choice. Okay. Unlike the RDM-controlled scales on the heads of lizards and snakes, so those are also reptiles, and it said common among reptiles. So we were only talking about crocodiles. So, yes, because crocodiles are reptiles. No, because it says that doesn't happen in lizards and snakes. Yes, because that tends to create irregular, semi-random scales. That's quoted in the passage, but it doesn't mention reptiles. So no reptiles are mentioned, right? No, because the body scales are much thicker than that doesn't mention other reptiles. So the answer is actually C, because C is the only answer choice that mentions other reptiles. So I can see how people got thrown off like I almost did, but C is the only one that actually mentions other reptiles other than crocodiles. Okay, number 2. Does the physical cracking model contradict the hypothesis that human hair contains beta keratin? So, it says beta keratin is, let's find that key term in the passage, right? So this is what we're looking for. Does it ever say human hair? No. That's never mentioned in the passage. So if it's never mentioned, so human is not mentioned. So that means I can cross off both my yes answers, right? So no, because beta keratin is a protein. No, because mammals and reptiles share many physical and chemical traits. So yeah, we know that humans have beta keratin. That's what makes our hair, right? But it doesn't say anything about contradicting it, right? So the answer is no, because humans aren't really mentioned here. So beta keratin is a protein, has nothing to do with humans, but this one does, this answer choice does mention humans. So the answer to 2 is D. Okay, so match the answer choice to the question as well. That's why these ones are a little bit more difficult. Okay. Does the information provided by the physical cracking model support the conclusion that tougher, thicker skin will lead to deeper, larger cracks? So where to look? I'm going to look at the physical cracking model. Support the conclusion that tougher, thicker skin. So where do we get there? Where do we see tougher, thicker skin? So thick, tough, and stiff, cracks in a pattern. Significant, meet 90 degrees. Crocodile head scales do not overlap, that they form by different means. Blah, blah, blah. Okay, so now deeper, larger cracks than more flexible, thinner skin. So we're going to look at this answer. Now, does it ever compare the skin here? It says crocodile skin is thick, but it doesn't tell me what crocodile skin is thick. So if I look at, it has a high concentration of keratin. As the crocodile grows, the inflexible skin cracks are seen like dry mud. Okay, so cracks, so in this sentence right here, this purple quoted sentence where it says this, it contains a high concentration, it doesn't tell you what kind of scale. So because it does not say what kind of scales, right, what kind of skin, that's going to lead me towards the no answers. And then let's just check. Skin thickness and toughness is genetically controlled. They never say that in the passage. Most lizard scales form during embryo development. They never mention those words, so that's not mentioned. It doesn't say toughness is genetically controlled. It says body scales are genetically controlled. So that means we're at the no answers for number 3. So now no, because while the model claims that skin properties affect scale size and shape, it does not detail the exact effects. That's true. It doesn't talk about toughness or thickness. And no, because it creates irregular patterns of cracking. That doesn't tell us about toughness or thickness. So that key term doesn't match the question. So you have to actually look at these in 2 different places. As you have to compare them to the answer choice, and you have to compare them moving forward. So number 4 and 5. Based on the results of experiment 1, is it reasonable to conclude that higher velocity projectiles are more effective at puncturing ceramic plate armor? So go to experiment 1, and I need higher velocity and then punctures. Okay, so I go to experiment 1, that's this one. Now let's see. As the launch velocity increases, the depth of penetration increases too. So I'm going to say that's a yes, and now let's find it. So I'm going to cross off my 2 no's. Right here, it's a yes answer. And then what did we write here? So we wrote, as launch velocity goes up, DOP goes up. So what answer choice matches that? That answer choice is B. So it matches the pattern of the graph. And then 5, does the reaction diffusion model, so this one's going back to the other passage, contradict the hypothesis that the shape of a rectile skull affects the final size and shape of head scales? So now we're going to the reaction diffusion model. Okay, so does it contradict that the reptile skull affects the final size? So let's read about what it says in the skull. Embryo during biochemical activators, reaction diffusion mechanism. RDMs have previously been used, feathers and hair. Similar pathways. The body scales are known to be developed through RDMs, suggesting that head scales form in a similar fashion. Can give rise to a diverse array of structures, including skin ornamentation, crest, horns, and pits. So it says in this one that it actually can be different. So does it contradict it? No, because of that quote. So we can cross off our yes answers. So no, because zebrafish do not have skulls. Zebrafish are never mentioned here. That's not mentioned in the passage, so we can cross off C. So the answer is D. And then when you need a quote for this, it says can give diverse array ... that quote. So that quote tells me that it says a lot of stuff can happen. Okay, and if a lot of stuff can happen for that one, then that means that it's not contradicting the answer. And that is the end of these first 5. And now we're going to move on through 6 through 10. So remember, I said this video is a bit longer today. Okay, so For question 6, it's still the same standards. A farmer is considering switching her herd from conventional feed to organic feed. She predicts the amount of milk her herd will produce will decrease as a result. So, let's see. A farmer is switching from conventional to organic. So this is conventional, this is organic. So the milk production for organic, right? Milk organic is lower than conventional. You can see by the difference in these two graphs. So she thinks her production will decrease. Is that supported? So yeah, those match. Decrease, decrease. So we can cross off the two no answers. And now we can figure that out. So yes, because her herd size will most likely decrease. We do not mention herd size. That's not a key term. So the answer is B. Yes, because the organically fed herd consistently produces less milk. And that is consistent in the graph. That's every single month. All right, number 7. Does the information provided by the physical cracking model, so again we're back, support the hypothesis that mammals contain beta carotene in their skin? So for number 7, does it mention mammals in the passage? So did we mention mammals in the passage? And if we didn't, that's going to give us our first one. So right here. Do we mention mammals in this passage? Keratin content, reptile. Nope. So it never mentions mammals. Right? No mammals are mentioned, so that means we're at a no. So now we have to decide between the no's. No, because crocodiles are reptiles, not mammals. And no, because beta carotene plays an important role in RDMs. Reaction diffusion mechanism is the other scientist, so no. So the answer is C. And C also because crocodiles are reptiles. So the whole passage, the key term is reptiles, not mammals. Number 8. A researcher suggested that diamonds are too rare to have been formed on Earth and proposed that all diamonds must have extraterrestrial origins. Does the information in the passage support this? So, let's look. High pressure and heat are required to convert carbon to diamond, as well as geotherms, so typical conditions on the Earth. Now, diamonds are formed by 4 natural processes. So, crustal, cratonic, meteoric, and pre-solar. Their origins: Earth's mantle, tectonic plate, meteorite impact, pre-impact meteorite. So this one is probably the only one that's extraterrestrial, but all of these are things that happen when it hits the Earth. So for question 8, we have 3 things that talk about the Earth, so that means it's a no answer. Now, why? Because crustal and cratonic diamonds form by natural tectonic processes. Yep. No, because diamonds only come from within the Earth. That's not true because we do have an ET one. And then these ones are Earth. All right,